I missed. I can start. Okay. Thank you. Thank you. Hey, good afternoon, everyone. My video is available. It is visible. Are you able to see me?
Yes, sir.
Hello. Okay. Thank you. See, basically today my lecture is on text analysis. I've seen your curricular for this particular FDP or this particular session that there are a lot of discussion is going on basically on the statistics. But for my case, my lecture topic is also statistics, but it is in different area, basically in text. How what we can do with the text? The text has enormous power, okay, in research, in day-to-day life, as well as for the mining of the customer review, finding out the brand brand image, what is the customer asking about the brand or telling about the brand, what are the discussions. So everywhere there are certain text. So those texts are what basically in unsupervised. That means that is what that is unstructured. In an open question, basically during the time of questionnaire survey, what we are doing, we are basically providing the respondent about certain close-end questions. It may be a scale, it may be in ordinal scale, maybe in nominal scale, maybe in Likert scale, whatever maybe. So that means we are giving some boundary to the respondent so that they cannot go out beyond the boundary, either strongly agree or strongly disagree, or within those strongly agree and strongly disagree. So these are the part when we are collecting the questionnaire, when we are surveying distributing the questionnaire and collecting the answers. Now the thing is that when if we provide certain open-ended questionnaire, what will happen? So in case of open-ended questionnaire, the respondent, they will provide the feedback. They will provide the feedback or opinion as per their wish. That means there is no boundary. Either strongly agree or strongly disagree or mostly agree, whatever. So here is a problem. The problem is that in case of Likert scale, or in case of your nominal scale or ordinal scale, there you have certain quantification. I mean you can quantify either one to 5, or 1 to 7, or whatever. That means depending on the responses, you can code the answer. So automatically we are getting the codes or numeric data from the questionnaires. But here something different. Say for if I ask you, give me the real time data, or give me the real time. Suppose you're in a company, so your boss is asking that give me certain data, what customers is thinking about our product or our company immediately, or live. So what we can do? That means I cannot survey, because for surveying the questionnaire, or for distribution of the questionnaire, you have to find out who are the customers. After finding out the customers, you have to distribute the questionnaire. After that, you have to wait. Nowadays, it a bit faster than earlier, as Google Form is here. So by Google Form, we can provide those things. But there are certain options where we can immediate scroll the data from the or scrap the data from websites, from blogs, from social media, from Twitter, from Facebook, from LinkedIn, what people are asking about the product. Okay, so if you have a Twitter account, you can collect the data by API. Okay, so there people are giving the short opinions. Suppose, say for example, Nike is in Nike's products. For suppose Nike launched a new product, a shoe. So after using, the user may provide certain review. In fact, we are providing review in our Flipkart purchase or in Amazon purchase. They are basically insisting on us, sir, please give us the rating, sir, please give us the some review on the product. So for what? For what? Are they collecting those things for as per for the wastage? No. Each and every data has certain meaning. So whatever thing we are entering or whatever thing we are writing, they require those data for certain analysis. So there you can do sentiment analysis. What is sentiment analysis? The anger. Suppose you have purchased a product Nike, and after a few days it got torn. Okay, so what you will do? You will go to you can reply to the your online seller that this is my invoice number. I have purchased the product on this day, and now it has gone defective. Okay, immediately you can make a review also that do not buy this product because I have lost. I have purchased the product and this is not a good product at all. So these kind of small things or these kind of reviews we are giving. So these are the things which we can find out from the text analysis. Okay, even there are certain analysis that is called market basket analysis. Market basket analysis is what? That is also through R or Python or certain data are there. Like nowadays for data science, mainly R, Python, Swift, Ligra. These are the languages. They are already they are the market leader. Even R is using by Facebook, R is using by Google, R is using by Airbnb. These people. So what they're doing basically, they are basically getting all the data. The total business market is basically the data. So by analyzing those text, we can find out what is the customer is thinking about us, whether they are happy with the product, whether they are not happy with the product. And in case of your market basket analysis, in your Amazon or in Flipkart, you may find when you are ordering something, immediately in lower portion you will find another thing, that is people also buy this. Suppose you are purchasing a mobile phone, automatically you will get a mobile phone cover. People also purchase this one, isn't it? That is market basket analysis. That means what are the associated product people may buy. For example, from Spencer, you are purchasing, say, milk. Automatically, in lower portion, you will find people also purchase these products, like cheese is there, like bread is there, like other things are there. So this is market basket analysis. So there are a few things which will go one by one. These are the things we can do with the text analysis. That is why text is very important in marketing analytics as well as in our literature review also. We are the researcher. We are the scholars. So basically, what we are doing, we are doing literature survey. We are doing literature research, literature review. So those things are also can be done up to certain limit through the text analysis. Now I am coming one by one. Up to this, it is okay? Anyone?
Yes, sir.
Okay. Thank you. Now my screen is visible.
Yes, sir.
Okay. Analyzing text data with R. So that is the today's topic. One minute. Yes. So full screen mode is on now. Hello. Are you getting
No.
full screen? Are you getting full screen mode?
No, sir.
Wait.
No, sir.
Oh, wait. There are certain problem in full screen mode. So what I'm doing? It's okay. It's visible.
Yes, sir. Visible.
Okay, so analyzing text data with R. Already what I have told till now, that is basically the introductory part or introduction. Now, what is R? We have said everything. We have said almost few things about the text analysis. Now, what is R? I hope all of you are now familiar with R because already 4 days has gone, isn't it? 4 days over. 4 days are over. Hello. 22nd to 26th, 4 days are over now.
5 days are over, sir.
Yes.
Five days are over. It was started from 22nd. Okay, so
Yes.
I am not going in details within R first. The basic part you I guess you already know, or already you have listened from other other yeah, teachers or other the resource persons. So R is basically R is a programming language. It's an open source software developed by Ross Yaka and Robert Gentleman in 1993. So R possesses an extensive catalog of statistical and graphical methods. It's a very much important word, that is graphical methods. R is very much famous for present for graphical. No other languages except Python, no other languages except Python has so much so rich graphical methods. We call this ggplot. So, and anyone can download the R from R project or RCRN will show that, and they can modify. But before modify, they have to justify what are the answers, everything. Now you can download the R for free of cost, and anybody can access the source code also. So that means the first thing is that R is free. So when we are going to purchase SPSS and other data and StratCraft, there are a lot of NVivo, there are Tableau, Atlas TI. There are a lot of tools are available for your qualitative data analysis and quantitative data analysis. But R is the strongest and R is most popular. Why? Because R is free of cost and huge community, community is there. There are a lot of community. Immediately you will get certain answers if you have certain queries. Okay, and the GitHub repository and CRN, all those are free of cost. That means the knowledge should be free. Okay, now it includes machine learning also. It includes machine learning, it includes linear regression, it includes time series, statistical inferences, and name a few. That means number of things you can do with R. Now R is written like mostly the libraries are written in R, but the computational tasks are written in C or C++. Now, why R is used for? R is used basically for statistical inferences. We have learned so many things like your cluster analysis, like your PCA, like your confirmatory factor analysis, your discriminant analysis. So many things we have done. So that is with R. And data analysis and machine learning algorithm. Machine learning nowadays it's a hot topic. Why? Everything we can automate through the machine learning. The very preliminary part will come later, but right now for this is the only thing right now you have to learn, that machine learning algorithm can be run through R. Only R and Python can have this kind of facilities. Now R can run everywhere. Everywhere means R is available for Windows, R is available for Unix systems and Mac of Apple. So Windows, Linux, and Mac everywhere R can run. Okay, so R is not only interested with academic. Academics are using R. There are a lot of academical work, not only statistician, even geography people, even other people, sociology people, even psychology people, even management people. They are also using R because of robustness of the R. Okay, so large companies also that like programming they are using R programming language like Uber, like Google, Airbnb, Facebook, and so on. Okay, now data analysis with R is done a series of steps: programming, transforming, discovering, modeling, communicating, and the results. So now a program, what is a program? R is a clear, accessible programming tool. So if you follow the syntaxes of R, and everywhere you can find lakhs of videos, lakhs of open tools for R. These are open. These are open. You can create your own. You can find it your own. You can apply your own. So there are a lot of things available. Now, Transform R is made up of a collection of libraries designed specifically for data science. I'll come to the library later. Discover, investigate the data, refine your hypothesis, analyze them. Model R provides a wide array of tools to capture the right model for your data. Some of you may use the econometric data, some of you may use the agricultural data, some of you have psychological data. So these data are different kind. So each and every data are different kind. So models are also vary. We have a lot of models in R. Now communicate, it can integrate codes, graphs, output, a report with R markdown, etc. etc. And sometimes the R are inbuilt with Java as well as Java programming language as well as with C and C++. Even some apps are also creating by the R. Now, pros and cons, it's basically advantages and disadvantages. These are open source, data wrangling can be done. You can present your data by any kind, an array of packages. There are lots of packages. Quality plotting and graphing, platform independent, machine learning operations, continuously growing. It's continuously growing. And then weak, or the disadvantages are a few: weak origin, but nowadays slowly the weak origin is becoming strong. And data handling, earlier it was problematic, so handling the data, but now it is okay. Now basic security is a thing, that how to people can use your code, so that securities problems are there. Now it's a bit complicated language and lesser speed. This one is very faced by me also. This lesser speed. Now sometimes are required huge time to processing. Okay, so lesser speed is really this is a very problematic thing. If you do not have any say i5 or i7 computers laptops, there are big problem. Earlier, even now also I am using i3 laptop, so I am facing some problem with R for the speed only. But now I have decided to take this, so that one, that SSD. I listened that these are faster. Anyway, so lesser speed is a problem with R. Now R, how to download R? Already you have most probably you have learned how to download R. I'm not entering into deep within how to download R. That is rproject.org, R project statistical computing. Then you have to download the R Studio also. R Studio is basically what making it is making R easier. It's an environment. It's an environment. Okay. So hope these two already you have done. This is a simple screen of R Studio screen, R script, R console, R environment, R graphical output. So these are the four quadrant, or four R Studio screen has these four parts. Okay. So these are the basic things we have with R. Now packages. R has today's date. I have just find out today morning 17,207 available packages in R. It's today's date. Earlier, 3 months back, 3 or 4 months back, it was 10,000. It was 10,000, but now it is 17,207. That means 4 months back it was 10,000. Now it's 17,000. That means within 4 months of span, it has increased 7,000 something. That means almost 1.75% rate. That means every 1.75 thousand per month. So it's not a matter of joke. Every time people are contributing something in our library. That's why R is getting robust. R is a robust language nowadays. Now R has certain built-in formats for importing data in many formats like CSV, TXT, XLS, and JSON. CSVs, that is basically values separated by commas. It is if you want to see, that is basically like Excel, but there are comma delimited are there, that it is separated by comma. So CSV files can be opened by any spreadsheet program like Microsoft Excel, Open, Office, Google Sheets, etc. Text, what we are writing in Microsoft text, that is a text format, that is called text. XLSX, that is Excel data. JSON is a format basically we use in Java, and JSON is text written with the JavaScript and object notation. Now tell me, up to this everything clear? Is it okay? Anyone please? Am I audible?
Yes, sir.
So but till now it is okay,
Yes, sir.
or is there any problem? Any query till now?
No, sir.
Okay, I am getting the response only from two people. Anyway, anyway. So now we'll enter into our main topic, that is text analysis. So have anyone, if you have any idea about text analysis? Anyone?
No, sir.
Okay. Anyone? Anybody? Anybody else?
No, sir.
Okay. Okay, let me start from very beginning.
Sir, I don't have.
Pardon me? Has anybody asked something? Okay. See, why analyze text?
No, sir. I tell that I don't have no idea about text
Okay,
analysis.
okay, thank you. Okay. Why analyze text? Already I have given a few ideas why text is important. Now there are two things. One is supervised learning, another one is unsupervised learning for machine learning. Okay, we'll come later what is unsupervised learning and one is what is supervised learning later. Now next go to text mining. This one, text mining is equal to statistical NLP, which is structured data, and data mining, pattern discovery. NLP is nothing, it's a natural language processing, or NLP, natural language processing. Okay, text mining is basically a combination of statistical natural language processing and data mining or pattern discovery of the data, pattern of the data. Now, basically text are source of information not commonly used in official statistics. Now, those people who are from finance background or from other background, we are getting data or company data from or white papers or from other journals. We are getting the data only statistical data. This is the company's ROI. This is the company's last year growth, last year growth. This is etc. etc. These are quantitative value. But text, how a person, how an employee think about his boss within the company. Suppose if I want to start a qualitative survey about a person, how popular is he within the company, whether he is a good boss or whether he is not, what the other people are asking about, or what the other people have idea about the company's product. So for those kind of thing we need to find the text analysis. Okay, now potential applications are automatically how we can use the text mining or text analysis. Basically text analysis is called sometimes text mining also. Okay, we can classify the data, we can classify the answers, we can find out the code description of jobs, educations, products. We can classify, we can quantify everything through text analysis. Now we can identify the activity code of companies from website text also. Web scrolling, we can say web scrolling, web scraping from websites, we can find out the important data. Now, detailed product identification from description on websites, classify cause of death from medical reports. So medical reports, in case of one important thing, in case of medical reports, there are a lot of things are written in medical reports, not only a tick mark or a coded word. There are a lot of what was happened to the patient, why is dead. So this kind of or some medical report are long medical reports are there. So to find out this, we have to approach through text analysis. Okay. Now, then sentiment analysis of messages. Already I have said that what is sentiment analysis. Sentiment analysis of Twitter, sentiment analysis of blogging, sentiment analysis in LinkedIn, through Facebook, we can do through social media. Okay. Now finding out the key terms and word association in literature review. It is very important. Though we will not discuss today this part. This is also very important part. The finding out the key terms and word association in literature review. We'll show how to find out the important how to find out the important terms, how to find out the important words, how to find out the maximum words used in a particular database. And later we can show you, if you're interested, that through there is an analysis that is called n-grams. N-grams can be evaluated in bigrams or trigrams. Okay, unigrams is basically the word, then bigrams, trigrams. We can use that to finding out the word association. Okay, how much important is it? Okay, so we are going towards the data, which is textual data. One minute, it's coming. Now, is the screen shared?
Yes, sir.
Okay. See, this is my R script. Okay. Hope you are familiar with the script. Are you familiar with the script? Hello. This 4-quadrant screen. Are you familiar with that? Anyone?
Yes.
Hello. Have you seen this kind of R screen?
Yes, sir.
Okay. Okay. See, here first I'll show you some basic things about R. About R. See, what is the requirement of RM? I'll tell you a bit later. Okay, I'll tell you a bit later. What is the significance of RM? So first, this is my script, and I want to show you something on data set which is preloaded in R. Okay, library of, I have to write, see, library function. I have to call library function. What is library functions? The library is the packages in R, some predefined data and some predefined programmings are already there. So that is called library. Now, if I go to library, there are, see, in console, you will find the library data set. Okay, now load data. Data can be loaded. What is the load data? We can load the already predefined some data are there, say empty cards. Now, if you want to find out anything in R, suppose you have received something or you have seen something about R, certain packages, but you don't know about the requirement of the data, you can put a question mark and write the package name and then type control enter. So you will find the control. You will find the what is actually it. See this one. This one will come in help. Motor Trained Car Road Test, MT cars. Motor Trained Car Road Test or MT cars. The data was extracted from 1974 motor trains and companies' fuel consumption and 10 aspects of automobile design and performance for 32 automobiles. So there are 32 automobiles were there, and 10 aspects were analyzed. Now see, if we write the head of MT cars in the table, we will find all the heads. These are the heads: MPG, SEAL, DIS, HP, DRAD, WT, QSEC, VS, AM, gear car. Now what are those? Those are basically MPG means miles per gallon. MPG. SEAL means number of cylinders. DIS, displacement. HP, gross horsepower. DRAD, and so on. Okay, so these are the table data head. Now, if I want to find the bar charts, see, you don't have to write these things in your programming. This is for your understanding only. Those has signs, and after that, this is for your understanding only. Now, cylinders, if you write the cylinders and then table, then the cylinders table will come. Okay, now bar plot of the cylinders. These are the bar plot of the cylinders. 1 second. Now plot for the cylinders. These are the plot. So total everything will come here. Okay. Now as it is not our motto to discuss these things, I am just showing you. We will come to text analysis later. Now iris. What is again iris? Iris is basically Anderson iris data. This famous Fisher-Anderson's iris data is said gives a measurement in centimeters of the variable sepal length, width, and petal length and width, respectively, for 50 flowers from each of 3 species of iris. That means there are 150 sample. Now, if you go to head iris, sepal length, sepal width, petal length, petal width, and the species. There are 3 species, so each species will come one by one. Now, if you go to histogram, see iris sepal dot length, you will get a histogram. For petal width, you will get a histogram. For length, a petal length. For for iris petal width, for everything you will get the histogram. Okay, now there are basic few things I want to share with you. That is the data types. Data types are basically numeric. Data types are integer. It may be double precision, character, logical, complex, and raw data structure. These are the types the data types in R. Now, say for example, numeric. See this part. Is it understandable? Hello. Is it okay? Hello?
Yes, sir.
It is okay now? Till now it is okay?
Yes, it's okay.
Okay. So numeric, first we go for numeric, say N1. N1 is our first vector. Say N1. Now N1 is what? The 20 data stored is N1. Now type of N1. Type of N1 is double precision. Again, say N2. N2, this is N2. Now, what is the type of N2? It is 1 plus 2i. It is complex number. 1 plus 2i is 1 plus I is complex number. So here it's 1 plus 2i complex number. Now character. Character C. It will show us error, unexpected symbol. Why? Because when we are entering any vector, so here we have to, for character, we have to, if you want to print these things only, we have to put double inverted comma, and the number and the character should be under the double inverted comma. Okay, now I have rectified it. Now if you put enter, now what is C1? That is C1, the name is here, and type of C1, it is C character. Okay, now again logical. L1 true, it will come error. But here in this case L1 again I have written true. What is the type of L1? It is logical. Why there are error? Because R is case sensitive. In true, capital T and small r I have written, so that's why it's showing. That's why it's showing what error. But in case of second part, I have written that L1 capital true. That means it is now it is okay. Earlier it was erroneous. Now data structure vectors. Say for example V1, we have say under V1 we have put it C1 2 3 4. So now V1 is what? V1 is here, the output is 1, 2, 3, 4. Now V2, see here I have written under inverted comma ABC. V2, now is dot vector V2, that means is V2 is a vector, we are asking to R saying true, answer is true. Now V3 false, again there is an error because true is written in small, T is capital, R in small. Now next one is okay. Is dot vector V3, it's a vector, yes, true. Now V4 C1 is to 20, 1 to 20. Now V4 will be printed as this one. V4 will be printed as this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 20. Now V5, now say V5 is C 1 to 20 minus 1. So what it will print? It will print V5 and C 0 to 19. That means 1 to 20 minus 1. Okay, so that will be that will subtract everything from subtract 1 from every digit. Next V6. V6 is to C, 20 is to 1. Now what is V6? Here is the answer, 20 to 1. Okay, so these are the simple storing vector for R. Now matrix. I guess you have already learned about matrix in our previous classes. Okay, so matrix. আপনাদের matrix হয়েছিল? Hello? Matrix হয়েছিল আপনাদের? Anyone please? Anyone please respond whether matrix is covered or not? Hello? Hello?
স্যার আলাদাভাবে ম্যাট্রিক্স হয়নি, তো স্যারেরা বিভিন্ন তাদের ক্লাসের মাঝে ম্যাট্রিক্স করিয়েছেন।
ক্লাসের মাঝে ম্যাট্রিক্স বলে দিয়েছিলেন তো?
কিছু কিছু, হ্যাঁ
হ্যাঁ, আমাদের ম্যাট্রিক্সটাও পরে লাগবে, আবার এটাও দেখিয়ে দিচ্ছি, ম্যাট্রিক্সটা আবার লাগবে, ঠিক আছে?
ওকে স্যার।
ওকে, so matrix is stored here M1 and matrix, see matrix should be written in that manners. C is a vector, then T, T, F, F, T, F, and n row is equal to 2. The number of element should be multiplier of the row. Otherwise, it's not possible to form a matrix. So M1. Now M1. What is M1? M1 is a matrix. See TTF. So matrix will load the elements like true, false, true, false. That means first row, first column, second row, first column, second row, first row, first column, first row, second row, first column, then first row, second column, second row, second column, first row, third column, second row, third column, in this fashion. Now if I write M2, another matrix, M2 matrix C 1 to 10, n row is equal to 5. That means that this matrix is 5:2 matrix. See, number of row is equal to 5 and number of column is equal to 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so these are the preliminary things about the integer, about the vector, about the matrix. Now we will come to our next phase, main thing, that is text mining. What is text mining? Now again I am going back to your presentation, PPT mode. So these are the few things that is very much important for your R basics. Now this part already we have done. Why analyze text? Now text mining in R. This is for people who wanted to learn the essential tasks required to process text in meaningful analysis in R. Most popular and open source programming language in the data science. Now, natural languages like English, Hindi, Mandarin, Bengali, Marathi, these are different form of languages. The semantic or meaning of the statement depend on the context. Suppose if I tell uh, say আমাদের যেমন বাংলায় বলি না আমরা আসছি, when we are going back, we are saying to our elders আমরা আসছি, that means exactly আমরা কি আসছি ওখানে না আমরা ওখান থেকে চলে যাচ্ছি. So in what context that particular word has used, for these cases semantic analysis can be done. So these basically we are instructing to machines by certain training data. We are trained the machine by the training data that you have to analyze if you get some same text later. Okay, so that is our main motto. So text mining help computers understand the meaning of the text. What is the meaning of exact the text? Now basic process and classifications. We are getting so many spam mail. So text analysis can find out, it can divide, it can classify the which are the spam mail, which are the no spam. Topic categories like current affairs. If we have a sorry if we have a newspapers soft copy, if we have a news post, we can categorize what kind of news is it, like a current affairs, like business, like sports, like entertainment, or any other classifications. So this can be done by R also. So learn which documents feature characteristics of classes is equal to learn a classifier. Predict from document features the classes for old documents with known classes, for new documents with unknown classes. Everything can be done through the classification or prediction. We can predict, we can create a model, which model can predict a particular word, whether it is from which class is it. Okay. Now text mining process, the core thing in our today's discussion, the text mining process. The application understanding text, there are certain applications like applications is what? Text pre-processing. What is the text? Why we have taken the text? What is there are certain part of pre-processing like semantic analysis, like syntactics, etc. Like features generation, how to create. That means when you are getting some data or when we are getting some text, we have to bring it into a corpus or into a bag. Okay, that is called corpus generation. Now text pre-processing is there. We'll see through R one by one. Feature selection, like what kind of features we want to calculate from that R analysis, like it's a simple counting or statistics or what. Okay. Now data mining, the classifications can be supervised, can be clustering, unsupervised, and search for patterns of modeling, topical analysis, sentiment analysis, opinion mining, etc., etc. Though we cannot cover everything in today's discussion, we go for the topic, we go for the word cloud and the frequency measurement only today. So analyzing the results and deployment of the results later. So deployment means where we can deploy the results. Now what is supervised learning? Supervised learning is basically for classification of the text. The training data is labeled indicating the class. Okay, what is training data? In simulation, it's basically simulation. We create some data and ask machine that it is your training data, it is your data, and later whenever you see something, measure with this standard only. আমরা অনেক সময় দেখি sometimes in our pathology report, suppose we are there in for blood checking, sugar checking. So there are certain what is the exact result of us and what is the standard data. So standard data is basically for machine learning is our classification of supervised learning. Okay, that is called supervised learning. So that means we are telling the machine you have to find or you have to check the letter data by this only. If our result is not at par this training data, the report will be like this. Okay, so new data classified based on the training set. That means observed data. Observed data, like in our statistics basic, like x bar and mu, like this also. X bar is our observed data and mu is our statistical data. Similarly, these things. Okay, now correct classifications can be done. The known label of test sample is identical with the class result from the classification model. Now, unsupervised, the class levels of training data are known, establish the existence of classes or clusters in the data. Now, good clustering method is high inter-cluster similarity and low cluster similarity, low inter-cluster similarity. Okay, so we'll come later. So these are the thing of cluster analysis. There are certain challenges. I'll come one by one. That is, will come in R itself. So what is the challenges? What are the challenges? And data mining. And these are the packages we'll use in our R. TM is for the text mining package, a framework for text mining applications within the R itself. TM package is very much important. Everywhere we need TM. Without TM, we cannot move. And Snowball CC, it is for stemming, explained below that an R interface to the C libstemmer library, currently supported language Danish, Dutch, these things. It is basically stem the word. I'll come in R. Now NLP, string R, word cloud, R color viewer, tweet R, ggplot2. Okay, so these are the library we'll use in our R in our R state. Okay, now next we have to move to R. So the theoretical part is okay. Now I am moving to practical part of text analysis. Please give me the response. Please response. Without your permission, without your permission, I cannot move.
Yes, sir.
Up to this, okay, na?
Yes, sir. It is clear.
Okay. So now again we move to R. Okay, before moving to R, I will discuss you something about my data. I'll discuss something about my data. See, my data is basically, one minute. My data is basically, you are able to see my screen now?
Yes, sir.
Yes,
Okay. Okay. So this is my this PC, the documents under R VVU, Vishwavarati University R. See here I have 10 PDF 1 to Z. Okay. Let us check what is A. Basically, these documents, what I am going to see, these are the literature paper. These are the journal paper. Okay, these are the journal paper on green marketing. Okay, these are the journal paper on green marketing. Now I want to find out what are the things are similarities within the green marketing journal papers. See, these were research on green marketing and green marketing strategy, critical analysis. This is number 1. This is number 1. say B. I have named it as A, B, C, D, E, F, G, H, I, J. Why? Because later when I'll import those files into R, I can easily find out, or I can easily target which was my paper. Otherwise, the whole name it will be difficult. It will be difficult to find out. Another, green marketing and its implementation in Indian business organizations. So these are the my papers. A 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 papers are there. Okay. Now, what we'll do in R there are certain things. Previously, we have to set it. See here, my folder name is VBU_R. Is it visible? VBU_R.
Sir.
Okay. See what I have to do. First, I have to go to session. Okay. This is very important. Otherwise, your program will run like you cannot find where it is saving. How to find it out? You cannot find later. You have to search. Okay. So session, then set working directory. Okay. Then choose the directory. I am choosing the directory. Okay. Now here again I am going to documents R VBU_R. I am opening it. So now see here it will come set weight R VBU_R. So my session is set. Now there is an interesting thing. I don't know you know or not. You have seen earlier or not. You can change the screen as per your requirement. You can change this later as per your requirement. So what we have to do? We have to go to tools, global options, and here it's coming. Appearances. Classic, Zoom, Lucida. See, if we go Lucida, and this is my Lucida, and now we can change. See this thing. This will change one by one. The font will change. Okay, and ambience also can change. It is black, dark mode basically, Dracula mode or dark mode. Cobalt, commission. This way you can change your screen. It's very interesting. You can change your screen. And normally in night time we can create the night mode. Okay, so you can do like this way. Anyway, now text mining. So already we have seen how to set the session. Now I am going to what? Now I am going to text mining part. So set the session directory we have already done. To begin, we load PDF tools later. Now here is a part. Say RM. RM is what it will do. It will remove the earlier data which is already in your memory or in your environment. Just find out the M1 part. Just find out the M1 part. Now I am mentioning Control Enter to RM M1. See, M1 is deleted. Interesting thing, if you do not clear memory, your memory, environment or memory every time, later you will face a problem. Why? Some tools that will be already in your memory, so when you run second time it will not take. So if your data changes and you are calling the same data set, if your data set is there, it is already in your memory, in your environment. But if you are calling the same library, same packages, automatically there will be an error. So that's why what you have to do every time after doing a programming or after doing our program, we have to do RM, remove memory. Now here RM M1 we have already completed. Now say for example RM M2. If we go for RM M2, check this one. RM M2 will be deleted. Clear. Now RM list is equal to ls, remove all data from the environment. So previous part we do not require. This data we do not require. So that's why what we are doing, we are, see this part will be totally clear. Control enter. This environment is empty now. This part is now empty. Now as install packages PDF tools, what is that? Basically in PDF, it's a PDF format, but the written, there are some data are there. So if we find out that data, that is not a text data. So that's why we have to convert PDF to PDF tools to text, and then we have to read the text data. We cannot directly go to the text mining or TM, that package directly cannot read data from the your PDF format. And our most of the research journals are coming with our PDF format. So what do you have to do? We cannot go directly to the data. We cannot find any CSV file. We cannot find JSON file. We cannot find text file. So we will get what? PDF data. So we have to create certain programming, or you have to write certain programming to convert those PDF data into our text data or readable data in R. Okay. So that is why we have installed here that install packages PDF tools. Now another thing, if this part is very much clumsy, you cannot see what you have written, so there is an option, there is broom sign, you can clear all your console. Now I am clearing all the consoles is clear. Now install packages for PDF tools. One or more of the package that will be updated by the installation are currently loaded. That means already loaded. Okay, so it will restart my R session, so I am not loading it. So this is already done. Next, create a vector of PDF files name using the list file functions. The pattern argument says to only grab those files ending with PDF. Why? Because see, there are a lot of files, R data, R history, these PPT files are there, images are there, PNG files are there, PowerPoint is there, Excel file is there. That will grab all data. But as I have said, only the PDF tools, only the PDF files. So this program or this command will only read the PDF files. So library PDF tools, this part is already there. That means when the red mark is blinking, that means some PDF packages is installing. Don't put any comment when it is blinking, the red button is blinking. Otherwise, your computer may hang. Okay, because of the R is directly accessing your computer's memory. That's why. Okay. Now library PDF tools, we have library PDF tools. Next, create a vector, already have said, say files. See, here the environment values are already stored, just stored. A.pdf, B.pdf, C.pdf. Now, interesting thing. Can you see this? A.pdf, B.pdf, C.pdf, this thing up to J.pdf. It is visible? Hello?
Yes, sir.
Yes, sir.
Okay. So what is A to Z? A to Z are those papers A, B, C, D up to Z. A to Z. Okay. Now there are certain interesting things. We'll use the vector to automate the process of reading the text of PDF files. The PDF function extract text into PDF text. That is our main instruction when we'll ask PDF to come to PDF text. Opinion is a vector. Say we use the Laplace function, then Laplace opinions length. That means see important thing. Say number 3. This is our number 3. Number 3 in our length in opinions. Within the opinions, the third PDF is which one? Third PDF is ABC. Let us check. The journal paper is visible?
Yes, sir.
Hello? Okay. Now what is the page length? See here. What is the page length?
8 page, sir.
8. This one? 8. What is this? 8. Now if we go to the 6th, say 6. 1, 2, 3, 4, 5, 6. 6 is our F. Got it? So in this way we can find out the PDF files. Say bar 12, this is there. So each and every PDF length we will get. Okay. Now for this part is I am not executing this part. This part is mainly for if you have a text file for that. File names list.files gateway pattern.txt. This is for text files. But as we have PDF files, so this instructions will occur. This syntax will work. Now, when text has been read into R, we typically process to some sort of analysis. That is called text mining or TM. First, we load the TM package and then create a corpus. Corpus means bag of words. That means all your 10 papers or whole 10 PDFs data will be in a particular corpus. Corpus is a bag. Basically, আমরা বাজার করার সময় কি করি? We are carrying a bag. So there's a list what we have to purchase, and we are purchasing everything and then put it into that bag. And after that, after returning to home, again we are sorting the products. Say potatoes, say other vegetables, say sugar, say salt. Again we are sorting it out. So that in between process, market to home, we are carrying those within the bags. Within the bag, all the product are within the bag. So similarly here we have the bag. That bag is called bag of what? Okay, so here we have to create library function. Library TM. Library is a function, TM or text mining function. Now this part is very important. The corpus function creates a corpus. As I have told, it's a bag. The first argument to corpus is what we want to use to create the corpus. What we'll do with the bag? There are something will be there. What we need to do, that is we have to tell to the corpus. In this corpus is the vector of PDF files. To do this, we use the URI source function to indicate that the files vector is a URI source. URI stands for Uniform Resource Identifier. That means all are uniform identity resource identifier, that is PDF. Okay, in other words, with the second argument, we read control tells corpus which reader to use to read in the text from the PDF files. That means these are all PDF files. Now we have to read the PDF through text. We have to convert it into text. That's why read PDF is there. Now TM function will call read control argument. 1 second. Read control argument requires a list of control parameters, one of which is reader. So we enter the list of reader is equal to read PDF. Finally, we'll save the result object, an object, it is called corp. Within corp, everything will be there. So corp is corpus, a resource file, read control list. Now come to control enter. See this red button I was talking about. Don't put anything when this red button is blinking. Otherwise, computer may hang. Now corp. Now we want to see the corp. See here the content of 10 documents it's showing. The content of 10 document it's showing. Clear? Now, if we want to see, inspect a particular document. Inspect a particular document, say write lines as dot character under the corpus on the corpus 5th number document. Now let us check 5th number document, control enter. See, this is the our 5th document's content. See, this is the words within the 5th document. Now let us check. Let us check within the 5th document. 1, 2, 3, 4, 5. So 5th document, what is it? Say if you go to the last line, say let us check what is the last line. 35, last digit. 35 is there. Before that, indianresearchjournals.com. www.indianresearchjournals.com. Before that, what is written? This one is written. Let us check. MSME Startup Kit Book Export HTML 20. This one. So it's working fine. Up to this clear? Hello?
Yes, sir. It is clear.
Huh?
Yes, sir.
Okay.
Sir,
Up to, bolo.
yes, sir. It is clear.
Okay. Now we'll go for start pre-processing. So under the under this thing, under the within the corpus, all documents, all 10 documents are saved. Okay, now start pre-processing. What you have to do, see there are certain words with upper cases. D, Dylan, Linda, K, B, these are the upper cases. So first we are telling to whom, to corpus, convert everything in lowercase. Okay, convert everything into lowercase. So control enter. Everything will come to lower cases. Then remove potentially problematic symbols. See, there are backslash, dot, number, there are double inverted comma, single inverted comma, everything is there. So one by one we will remove those. Okay, see, remove potentially problematic symbols. To space, this content transformer function X pattern return, this is the G sub function. So everything will be removed one by one. These are your syntax. Corpus under this single inverted comma, full stop, double inverted comma, this. Everyone will be clear. Now remove punctuations. If any other punctuations we have missed, that will again be removed through this one. Remove punctuation, this one. Remove punctuation. Now strip digits. Strip digits is what? If there are any digits like 2009, 20, say here it is 20, 2012, this will be strips. Okay, because this part is not required for our text analysis. The number is not required. Now remove stop words using the standard list in TM. Remove stop words means can, we, see, the, article, adverb, verb. These are the stop words in English that can be removed. Here, stop words what we are using in English that will be removed. This one. Now again remove white space. White space means suppose we have this, some of us when we are writing mistakenly or sometimes we are putting double space. So those space are unwanted. Okay, or after a word a space then full stop. We can put like that also. So this extra space will be cleared. Let us check again that 5 right line character called fifth number. Let us check the fifth number of our data. See, this is our fifth data. Sorry, this is our fifth PDF. Is it visible?
Yes.
Hello. See, Indian research journals dot is not there. 35 was there earlier, that is not here. See, 35 is not there. 35 is not here. 20, 2021, 2012, 22, nothing is here. All words, all your digits are removed. Okay, so we have successfully pre-processed. Right now it's important thing is that typically a large corpus contains so many words. Okay, so many words means there are a huge number of words whose different forms we can use. For example, say for example, drive, D-R-I-V, drive, driver, driven, these are the things. Or say entrepreneur, entrepreneurship development. So these are the things can be added with the generic word. So here what we have to do, we have to bring the root word or the generic word. Otherwise it may be there are some classes of words. So that's why we will bring it to its root. Here is another example. See this one. For example, organ, maybe see organize, maybe organizer, maybe organization. Okay, so these are the word from a single or common root. Okay.
Sir, may I ask a question?
Yeah, sure.
Today, different kind of software are available in the online to convert PDF into Word or TXT file. Then why we need such kind of rigorous statistical tools to convert this?
Correct. Very, very good questions. Now, the thing is that those all the PDF converter, these will give you certain number of conversion. Suppose you can upload 1 at a time, you can upload 20 at a time, you can upload 10 at a time. After that, you will get a message, buy this or premium this. Isn't it?
Yes, sir.
That means every day, suppose you have 400 PDF papers. Suppose you have 400 PDF papers. I have one thing, one minute. Or 1 minute. See, another my one scholar's paper, research is that these are PDF files.
Yes.
How many items? See there. This one, corner, leftmost corner.
Times.
209. So when you put these 209 at a time, those online softwares, they will not give you the conversion. Number one, correct. Number two, after 10 or 5, they will insist you to purchase. That is why R is open source software and R is free. Only certain, you have to learn only certain instructions to say learn, to say R, they convert this.
But there are different software. May I use for 10, one software for 10, another software for more 10 papers?
Okay.
Like this.
Okay, so those cases you can only convert into text. After that it is bit difficult, isn't it?
Yeah.
Like you can do with NVivo, you can do in other softwares also, but that is costly. That's why already I have said, that is why already I have said that R is free of cost, R is open source, and maximum students, the scholars, they are basically purchasing of those software is bit tough for them. So that is why R is important. Are you getting my point?
Okay.
Okay, so in case of other softwares, you can convert the PDF to text only. I agree. I agree. You can convert it. But thing is that in R, in a single software, you can do everything. Or in Python, you can do everything, which is not possible by those softwares. And those softwares, if you use the free online, it is okay. But after certain, they may block you for that day. They will say your daily limit has crossed. I have tried also. I have tried. Okay.
Okay, sir.
Okay. Thank you, Pralay. Thank you for asking. Okay. Now where we are here. Now organize, this will be reduced, and by the document will be stamped through Snowball CC. Okay. Sorry, through Snowball C. Basically a lib stemmer library in R that works for this library Snowball C. Now use library Snowball C. Now we want to stem the document. Now corpus, again say I will check the fifth number of our PDF. So that is in corpus, that is totally, now it is okay. Now it is okay for us. Now, important thing is that there is more advanced procedure called lemmatization. Okay, so we have what we have done till now, pre-processed. We have stamped the document. We have changes the document to T lower. We have removed the punctuation words. We have removed the numbers. But there are certain things like grammar, the grammar related thing, that is more sophisticated version. If you want to use, again we have to put it, but that's a bit complex syntaxes for using POS tagging. That in POS tagging, this one, POS means part of speech, which is related to noun, adjective, adverb. So if we are taking the noun, suppose we are stemming some documents or stemming some word. So what is the significance or what is the difference between original word and stemmed word? Okay, so these are the some few problems we have to taken care of. As it is unsupervised learning, so this problem will occur. Definitely this problem will occur. But in case of supervised learning, these problems may not occur. Okay, so POS or part of speech tagging is a bit different. Like for example, again, for the output of the corpus may show few problems like attaching two words. Those two words say market finance. It is actually exactly know what it has been happened to this word. Suppose market and finance are two different words and was separated by a comma. Okay, it's separated by a comma and there were no space. Now when we have suppressed the comma, we removed the comma, automatically this word has attached in together. So we have to take care of that market finance. Market and finance should be different word. So here another function, that is G sub, which can transform the content. Say corpus, that is our corpus. Transform G sub pattern organize to organ. Organize, it's a single word, we can to come to root. Organize, another word, we can bring to into root. And govern. Sorry, and there was space that has been somehow erased. So govern this in enterprise. It can come to enterprise only. In will be removed. So this small error may occur. So we have to take care of it. And even these small errors are may not be a very very much troublesome for us later. So these are the few words only. We can ignore later also. Suppose this one pattern team hyphen team and team, say team management, team hyphen management. So when we are separating those team and management, this thing must be removed. Okay. So we'll perform this task one by one. Okay. Now, my stop words. When we have put it the stop words with English, see where is the English? This one, corp tm underscore tm map corp remove words stop words English. These stop words in English are common stop words, but we can put another stop words as per our requirement also, which may be overlooked by the particular syntax. So get, see my stop words within the vector get, can, say, one, way, well, will, tell, something. These stop words has no significance in our corpus. Okay, right now this we do not require. So we need only important word from the corpus. Okay, now next my stop words. Now we are performing this my stop words. These are already removed. Now corpus tm map corpus remove words. Now again inspect. Again we are inspecting. Now it is your exact thing what we required. These are called pre-processing. Like our cooking. Before we go to cook, we need some pre-processing of the vegetables. We need to pre-process some meat. We need to pre-process some rice. So like this way, for the data analysis, we have to pre-process first. Okay. So up to this, now we have to go PPT again. Now we have to go PPT again. One minute. My PPT is visible now?
Yes, sir.
Okay. See, here what we have to do. Here, the corpus is basically what? The corpus is bag of words. All words are there within the bag. Now we have to convert in document term matrix. Document is what? Document is the document of those 10 documents. A, B, C, D, E, F, G, H, I, J. Those 10 documents, and term is the word. So per document, how many words are important? We have to find it out. Sometimes we call it as term document matrix. So that is why I have asked you whether matrix has been or matrix thing has been done or not. Okay, so that means you can imagine 10 documents, there will be how many number of terms, which terms are important for our this analysis. It's basically a mathematical matrix that describes the frequency of terms that occur in a collection of documents. How many times a particular word has been arises? How many times it's appeared? Okay, that is our called term frequency. In a document term frequency, rows corresponding to documents in the collections and columns corresponding to words. I'll come later in the next PDF PPT only. In the next slide only, I will show you how it is calculated. So that means the 10 documents are there, isn't it? We have collected 10 documents, 10 PDF, or do you have shown? Can you remember?
Yes, sir.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is our 10 documents. So under 10 documents, how many words has been repeatedly appeared, that we will see. If a words occur in a particular document, then the matrix entry for the corresponding to the row and the column is 1, else it is 0. That means if a word in a particular document appear, corresponding frequency will be 1. If it is appeared twice, corresponding frequency will be 2. If it is appear for 10 times, the corresponding frequency will be 10. In that way, otherwise it will be 0. So that means when creating a database terms, the appear set of documents, the document term matrix contains rows corresponding to the documents and columns corresponding to the words. Now, for instance, say this one. Suppose my first document contain, say D1, document D1 contain, I like databases. D2, I hate databases. So how many documents are there? 2 documents, D1 and D2. So total bag of words are 1, 2, 3. It is repeated, 4, it is repeated. So that means 4 word will be there, column 4 words, the number of varieties of word will be 4. 1, 2, 3, 4. Now for first document, I appeared, like appeared, hate is not appeared, that is why it is 0. In database, again it is appeared, it is 1. For D2, document 2, 1 is appeared, like is not appeared because I hate database written. Hate is appeared. Again, databases is appeared. So for I, it will be 2. For like, it will be 1. For hate, it will be 1. For database, it will be 2. Clear or not? Tell me. I want answer from each and everyone, whether it is clear or not. I'll repeat.
Yes, sir.
Clear. Others?
Yes, sir.
Others?
Yes,
Okay.
sir.
Okay. Others?
Yes, sir.
Others, please. Okay.
Yes, sir.
Up to this clear?
Yes, sir.
Okay. So that is document term matrix. So see, it's a matrix. How many row wise document? D1, D2, and these are the term. That's why it is called DTM, document term matrix. D1, D2, these are the term. Now, one second. The terms and how many times they appear. The more sophisticated words can be used. Typical examples like TF IDF is there. We have not applied TF IDF here. TF IDF is what? I'm coming to this. See this. So we have talked about that DTM. Now for this, we will come to DTM. Again, document term matrix for whom? For the corpus. Corpus means all the words of that bags where we have 10 documents. Now DTM. Now what is the DTM? See. This one, document term matrix, document 10, terms 3829. Now I can go to here. It's interesting. See, document term matrix here. Document is 10. This part is visible.
Yes, sir.
I have highlighted. Yeah, I have highlighted blue. Earlier, I have put it another document when I was preparing this R console and PDF PPT. So that's why I see here it is 3807 total term, but now it has been changed to 3829. Okay, that is dynamic. That's why R is dynamic. So document term matrix 10 documents, total term is 3829. Now, non and sparse entries. Sparse means zero. Sparse means zero, no entry. This entry is called is a sparse. This part is a sparse. Say zero is a sparse. Here zero is a sparse. So as it's a huge number of word, it's a huge number of word. So maximum will be sparse, because a particular word can occur in a document 1 but may not occur other document. That's a huge. So when your number of document is large or number of term is large, the sparsity will be also large. So that is why non-sparse or entry is 8428, that is non-sparse, and sparse entry is 29,862, almost 3.5 times, almost or 3 times. So sparsity is 78%. Okay, sparsity occurred, and it's good. Now maximum term length in 76. 76 number word is 76 maximum term length. One word having 76 number of term. One term has term length. That means how many characters are there? 76 in a word, single word. Later we can find it out through n-grams, but now it's not possible to show through n-grams, and separate programming is there, n-gramming, bigram or your trigram. Through that we can find it out. Now waiting is term frequency. Okay, waiting is term frequency. Now what is term frequency? Here it is written what is term frequency. Term frequency, TF IDF, or term frequency or inverse document frequency, is a numerical statistic. Which reflect the importance of a particular document collection in the corpus. Here, this is 10 into 3807, not 3807. This is 10 into 3829. 10 into 3829 dimensions matrix, in which 78% of the rows are 0, and necessary for us use this representative when the maximum term length is 76. Now TF is number. What is the mathematics behind the TF? TF is equal to number of items term T appears in a document. Number of items, number of times a particular term or word appear in a document, that is T, divided by total number of terms in the documents. Suppose journal that is appeared 3 times, and there are say 500 word for a particular document. So TF will be 300 by 500, 3 by 500. Similarly, IDF is inverse. Inverse is what? Logarithm of total number of documents by number of documents with term T within it. So and value is TF into IDF, or in short we say TF IDF. Term frequency, inverse document frequency. It's a big mathematics band that if anyone interested, I can show you later. Okay. Now the TF IDF is again here, given here. Now again go to R corpus. R. So DTM we have already show the DTM. Now row names of the DTM is saved as files. Okay, row name DTM files. what it will do, collapse the matrix by summing over columns. That is frequency. Next thing, that is frequency, freq, call sum as dot matrix DTM. Collapses matrix by summing over columns. See this one. I'm going to the PPT. See, this is the matrix. So I appeared twice, 1 plus 1, 2, like 1 plus 0, 1, head, 0 plus 1, 1, database, 1 plus 1, 2. So this is just summing. We are summing the frequencies. Here, S dot matrix or call sums, that means column sums, sums of columns. We are doing sums of columns of the document term matrix. So here the document term matrix is 10 into 3829. 10 into 3829, that is my document term matrix. And here we will do algebra for matrix algebra. So what is the total number of call sums, column, every column summations? Okay, so freq. See, freq is here 2 1 1 1 2 and see 1 is to 3829. So total term is how much? How many? 3829. So frequency named now 1 to 3829. 3829 words. How many times it appears? It will show here 2 1 1 1 1 2 and lot of things. Lot of words are there. Okay, now come to length. This length of the frequency will be equal to this length, term's length. How many? See this one, 3829. It is equal to our this term, 3829. Okay, now length is over. Now we'll go to create a sorting order. That means how many times that frequency or they appeared. Order frequency decreasing. Again, list of all terms in decreasing order and free write to disk. Say this one. Now the result is coming one by one. See. These are the 3829 numbers of 3829 numbers of your term or word. See. So maximum used word is this one. Grid 1274 times. Then market 841 times. Then product 463 times. Then environment 404 times. Brand 382 times, business 351 times, consume, it may be consumer, it may be consumable 342 times, journal 231, manage, it may be manager, it may be management 218 times, farm 212 and so on. Okay, now we'll have another write.csv freq order to frequency CSV files. We need to store it. So where it is stored, now see where it has been stored. Go to this VVU. This is our session. Within the session, what frequency has taken here. This is today is 27th February 2021 for 16:40 p.m. 5 p.m. Now it is 4:45 p.m. See what frequency. It's coming. That is the problem with the R. Very much slow. See, these are the word green. These are the word. So these are the total words. Basically, you can say terms. So up to how many? You can find it out. 3830 That was 3829. It is 3830 because we have left one row earlier. So it is 3829. So all we have left this row. So all the terms will be stored here. Okay. Now let's check the number of terms occurred more than 100 times. How many things, how many terms has appeared 100 times, more than 100 times. But what will take place alphabetically? See, this is the syntax for that. Find frequency term, find freq terms, DTM within the DTM, document term matrix. Low frequency is 100. That means more than 100. Enter. See, active also benefit brand, business, company, competitor or competition, consume, CSR, custom, develop. These are the words. See, highest we have seen green, but now it has green is here. Then we have seen market, market takes place here. It will come alphabetically. Okay, so these are the words we can see how many times it has appeared. So it's important for us. Now, another interesting part. The interesting part is that we can find out what correlation. What correlation? For example, we can check the correlations between green and other word. Why? How? Because how many times green appeared, what is the correlation with other terms that will also appear? Okay. For example, it's very much interesting. Say for example, say practice. Say green. Anyone can say what is the correlation value? Minimum value and maximum value? Anyone? Value of correlation, minimum and maximum?
Plus 1 to minus 1. Plus 1 to minus 1.
1 to plus 1.
Okay, here we can see positively. Okay, suppose the green 0.6. That means which are the word in DTM associated with green more than 0.6? Control enter. Red button is here. See, these are the lot of word in each document. In each document there are a lot of words associated with green. Now let us see. Journal is green. Journal is with journal. It is maximum 0.94, towards 0.94, examine 0.9. These are the words correlated with the green. Now let's see how many 0.9. How many word or how many term correlated more than 90%. Journal, toward, examine, effect, appear, contradict, pronoun, faculty, intent. These are the words. Similarly, for practice, say let's check with practice. Answer, debate, emphasis, fig, forest, goodwill. These things. For develop, these are the words. For enterprise, this. So these are the word correlation. So there are n-grams. N-grams through we can do network correlations, and the figure will show you the which word how close it is through the how close it is with another term or another word through the network analysis. Now go to basic graphics. Now we will go to basic graphics. Graphics, that is for this reason R is famous mainly. Those things we can do with the other languages also, but R is famous for his basic graphics like ggplot and other plots. Like, see, now we can minimize the console. Okay.
Sir,
now,
may I ask?
Yeah, sure.
If I convert the PDF text and remove some word, quotation, etc., then can we spin the article?
Can we?
Spin the article means change the sentences.
Change the sentences means?
means in order to bypass the plagiarism.
No, you cannot do that because you are just finding it out. You are finding it out. For that, different software is there to finding out, because see, for checking the plagiarism you have Turnitin, you have other softwares. Okay, you have other softwares, but in this way it's bit difficult to remove the plagiarism.
Okay.
It's bit difficult. I don't know. There must be certain routing for route just the stemming what we have shown in our earlier steps. The maybe Turnitin and other people they are doing that, but I don't know the exact process. But that is what you are asking. That will be a bit difficult because each and every term, so all the terms are coming to a stem document and root document. The roots are very only for machine, but if you want to try to do that, that will be much difficult. Okay. Okay,
Thank
now basic graphics. Now the graphics is what? Graphics is, these are the words. We can find out the maximum word which is used in text within the corpus. Okay, here the first line creates a data frame. This was WF is a data frame and term's name is freq. That freq we have already used, and occurrences are freq. That means dependent on frequency, we will use the data frame. In this case, there are term and occurrences respectively. ggplot telling it to consider plot only that occur more than 100 times. See, ggplot is said occur more than 100 times. Okay, and AES basically aesthetic, or we can say sometimes given the axis value, terms and occurrences. I am coming one by one. And PF is a basically vector where we have stored everything. PF plus, these are the identity. What is the identity? Basically option for the geom bar to ensure that the height of the each bar is proportional to the data value that is mapped to the y-axis. Okay. Now come to this. Let's check. Is it visible? This bar is this graph is visible?
Yes, sir.
Occurrences term. See, occurrences term.
Yes, sir.
Now, so see, if we change the angle, it is basically for the x-axis the value. If we change the angle, say to 45 degree, 45. Control enter. Just follow these lines. -45 angle. Okay. Now for the understanding, easy understanding, we again give it to 90. Okay, it can be export, save as image or save as PDF, whatever. Now for as the other files are also in PDF in that particular your session in my session, so I am saving it as image. Preparing to export the plot. See, the here width is very less. We can put a higher number, say 10 and 4, say it is 734. Now save. It's required some time to come. 1 second. 04. So is it interesting? Hello? See, is it visible? Hello?
Yes.
Green. See, maximum term is green. Green is 1274. Green was 1274. That is the tallest. This is the tallest bar. Then market. If we go to our programming, this part, this part. No, it's not coming. Okay, so green is our tallest. So far I can remember it was 1274. So 1000. Then see this one, more than 1200. Around 1000 was 800 something was market. First, second, third, fourth, and on this one, and so on. These are the occurrences or frequencies of the terms which we in our corpus. Okay. Now next thing is that word cloud. You might have seen there are a lot of word clouds in the different areas, like in your image, in Google image, you have seen the lot of word clouds. Word clouds is what? First we'll go to a library, that install the library, that is library word cloud. Then setting the same seed each time ensure the consistent look across the clouds. Set.seed 50 example. Now, word cloud names frequency, minimum frequency is 100. That means we will take only those words which has appeared more than 100 times. Now check. Interesting. So again, see this part. See, green market environment. This has been due to certain problem. It is not coming. My machine problem. So these are the word wise. These are the appear. These are the frequency wise. The frequency wise the size of the word will appear. This is called word cloud. Number of word it will be generated. Okay. Now this can be again. This can be again. We can add color. See, word cloud name frequency same thing, only colors, the color viewer package need to be installed. So color viewer is there and that too. See, with the color viewer, this color will come. So again, you can export this one, say save as image. So this is your color. This is your color. Okay, this is called word cloud. So through word cloud, easily you can find out which are the words are most important for your research, or which are the word is maximum times is used in your documents. Okay, so I am saving it. So again, it will save to my database. This one. Okay, Up to this is my main today's agenda up to this word cloud. After that, I mean, after frequency and after word cloud, there are a lot of things to do with the word and word mining or text mining. If I get some opportunity later, I can show you sentiment analysis. Sentiment analysis is what? Through Twitter data for a certain product or for a certain trend, whether people are angry with the product or service, whether people are happy with the product or service, whether people are sorry with the service, whatever the thing, you can find it out through the sentiment analysis. Even companies are using those sentiment analysis in exit poll also. During the time of election, in exit poll they are using that. So there we can finding out the degree of sentiments also. Okay, and this word cloud, one part can be good sentiment, another part can be bad sentiment. In this way the analysis can be done. Okay, then cluster analysis. Cluster analysis, what is your document? Whether your document is under which cluster, the cluster dendrogram can be occurred, can be created. And depending on the Euclidean distance, what we have seen in our cluster analysis, you can finding out which clusters are similar, which clusters are which documents are similar, or which your papers or journal papers are similar, which are not similar, and which are from far from another. You can find it out through cluster analysis. Network analysis, the pictorial graphic representation can be find out through the network analysis. Topic modeling, it's another important thing. Topic modeling is that it is very much using in your in your literature review. Suppose you have 500 number of documents. So searching or reading each and every document for the supervisor and for the scholar, it is bit difficult for period of time. Sometimes the topic modeling, what it shows us that the particular document, it's depending on which topic. It's depending on which topic only. Okay, by that you can find the particular this topic is depending on whether it is related to your research or not. If it is related to your research, then you can go through the topic, otherwise leave it. Because through keyword searching, it is not possible. There are every day there are thousands of databases are submitting. In repository, Google repository, today suppose you are giving your keyword, after tomorrow you will get another 100 documents has been submitted. So how you will find? So the next thing is our machine learning. The machine can be instructed, machine can be given instructions to find out, because it is not possible for human being to find out each and every word or each and every data. Oh, so that is why the artificial intelligence, the artificial neural networks, the deep learning, machine learning, AI. So these things are coming slowly. Okay, and here today I have given the 10 documents, which is here I have given 10 documents. You can put 400 documents, you can put 500 documents. Okay, so these are the things we have given. We have seen through the R. You can learn R, you can learn Python. Everything is there for as per your purposes only. Okay, now top n-grams. N-grams is what? Through n-grams we can find a single word, unigram, bigram. Bigram is very much important, very much important for finding out the variables. Suppose you are going for a PCA. You are going for a PCA, principal component analysis. So there, what is important for you? Which are the variables are important for you? So there you can find it out through the n-grams or bigrams. Okay, so unigrams may vary. These are the unigrams. One word, single word called unigrams. But bigrams, when two words occur simultaneously. Say green, if we say green marketing, so that is bigram, green marketing. Green marketing activity, that is trigram. Okay, so these are the work can be done with the R, with the Python, with the machine learning also. Basically, these are the two learn your R and Python. These are the main two competitors here for the machine learning and artificial intelligence, whatever. Okay. Okay, so thank you so much. Up to this, my 1 second. This was my PPT. Source corpus mining. So compiled from these are the papers and these are the websites from where I have compiled all those things. Basically, this is the job of the data scientists. They are the famous data scientists, and we have applied the work in our own job. Okay. So thank you. So if